Standard 11 Chemistry Unit 3 Classification of Elements and Periodicity in Properties Part 6. As we know that the size of the atom is very small and it is nearly about its radius is 1.2 angstrom. So there is no practical way by which size of an individual atom can be measured. To estimate the size of the atom, non-metallic elements, metallic elements, and for noble gas there is covalent radius, metallic radius, and van der Waals radii or radius. First of all, let's see about what is atomic radius. Atomic radius, it is nothing but the distance from the center of the nucleus, of the outermost shell of electron in the atom of any elements, and it is called atomic radius, or in another word, that half the internuclear distance between two adjacent atom of the element, half the internuclear distance between two atom of the elements, and it is called its atomic radius. Here the atomic radius for metal, it is considered to be as metallic radius, and for non-metal there is covalent radius. First of all, let's see about metallic radius. Metals like copper, sodium, etc. Here half the internuclear distance, this atom A of the metal elements, or atom B, the distance between two atom, and its half value is d by 2. Half internuclear distance that separating the metal cores, and metallic crystal. It is called metallic radius, or in another word, half the distance between nuclei of two adjacent atom, two adjacent atom of the elements is called metallic radius. For example, for copper, its distance capital small d, that is 256 picometer, and its metallic radius is d by 2, that is 256 divided by 2, it is 128 picometer. Now let's see about covalent radius. Here the covalent bond is formed between two atoms of the same elements. For example, chlorine atom has one single pair of single or unpaired electron, and they shared one electron, and they make single bond. Here the covalent radii is for non-metals. The half the internuclear distance is capital D, and its half distance is d by 2. The half the internuclear distance between between two similar atom of any element which are covalently bonded to each other by single covalent bond, and it is called covalent radius. Half the internuclear distance between two similar atom. For example, chlorine chlorine, fluorine dash fluorine, etc., which are covalently bonded to each other by single bond. It is called covalent radius. For example, the covalent radius between two chlorine atom, and it is same elements in the mix chlorine molecule, by sharing of one electron, they are singly bonded atoms. Its distance is 198 picometer, and its half distance is 198 divided by 2, it is equal to 99 picometer. Now let's see about the next radius, that is van der Waals radius. This is mainly for noble gases like helium, neon, argon, krypton, xenon, etc. Half the distance between is the distance capital small d, and its half distance is d by 2 between closest approach of the two non-bonded atoms. They are non-bonded atoms of the given elements. Half the distance between closest approach of two non-bonded atoms of the element. That means they are not covalently bonded by sharing of electrons. For example, helium, neon, argon, etc. They are not covalently bonded to each other or the same atom of the elements. So half the distance between closest approach of the two non-bonded atom of the element is called van der Waals radii or radius. Okay, so here van der Waals radius is greater than metallic radius. Metallic radius is greater than covalent radius. This is important, not for MCQ. Now let's see about the atomic radius or atomic size of the elements in period or in group. As we move from left to right in period, atomic size is decreases, and as we go down in the group, atomic size is increases. How? For example, in period, as we'll move from left to right, atomic radii is decreases. For example, in second period, the elements are lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. It's noble gas, and for noble gas it's van der Waals radius. So as we move from left to right, its atomic number is gradual increase. Now let's see about their electronic configuration. For example, lithium atomic number is 3, number of protons are 3, and its number of electrons are also 3 because of its neutral atom. Its electronic configuration is 1s2, 2s1. For boron 5, number of protons and number of electrons are equal to 5, 1s2, 2s2 and 2p1. For oxygen, proton and electrons are 8. Its electronic configuration 1s2, 2s2 and 2p4. Here is the valence shell. Valence shell, that means the electron remains in outermost shell. Here is the first cell, or it is second cell, n equal to 1 and n equal to 2. Second thing here, as increases the number, atomic number, nuclear charge of the nucleus is increases, and the distance between nucleus and electron remains constant, because the value of the valence shell remains constant. So here, electron in same valence shell and nuclear charge increases with increasing atomic numbers. That resulting increases the attraction of electron to the nucleus. Here, as the charge is increases, the attraction between outermost electron of the cell is increases, and as a result its atomic radius is decreases, means atomic size is decreases. Now for group or in a group, as we move down in a group, its atomic size is increases. How? For example, or for group 1, and its elements are known as alkali metals: lithium, sodium, potassium, rubidium, cesium, etc. Here number of protons and number of electrons are as same in its atomic number. Proton for sodium, the electrons are 11. Here for potassium, proton and electrons are 19. Its electronic configuration is 1s1 1s2, 2s1 for sodium. It's a neon, and 3s1, and potassium for argon, and 4s1. Here the valence shell of the atom is increases. With increases the atomic number, means here the distance from the nucleus to electron is increases, and as increases the distance from the nucleus to electron, its atomic size is increases. In group from up to down, principal quantum number n is increases, distance from nucleus to valence shell or valence electron increases, and therefore atomic radius is increases, means atomic size increases. Okay friends, so next time we will discuss ionic radius. Thank you very much.